Okay, Karate is 100 integrals number 40. If you look at this question, we need to integrate 3x plus 2 divided by x times by the product, times by the x plus 1 to the power 3. In order for you to do this question, if you just look at the denominator, that's the total power is power 4. The numerator power 1, so obviously we need to use the partial fraction to decompose these integrals into partial, different smaller fraction. That's why it's called partial fractions. So the first step we need to do is we need to be able to actually know how to do that, right? So we need to let 3x plus 2 over x plus 1 to the power 3 into a over x. So you take x as one of the factor. Now the next one is a bit tricky. This is degree of 3, power 3 here. So we need to separate that into 3 parts as well. So that gives you plus the x plus 1 to the power of 1, and then the x plus 1 to the power of 2, and then the x plus 1 to the power of 3. By doing that, you will just need to have the linear, like a constant number to be put on the numerator. So that gives you b, c, and d. All right, so that's the way of doing it. Now, once you finish that part, we just need to find out the common numerator for both sides, and then we make them equal to each other. All right, so for the a here, we need to multiply by the x to the power plus 1 to the power 3. So in order for us to have the same denominator, so if you follow this pattern, we get a multiplied by x plus 1 to the power 3, b, we need to multiply by x first, and then x plus 1 to the power of 2. Seems this one already power of 1 here, so we just need a power of 2 to get to power 3. For the c, I need to times this one by x as well, and then x plus 1, it's enough. And the last term for the d, it's only missing, x, so therefore you just need to times by x. So everything here is equal to 3x plus 2. Now, once you have finished that, we need to use some substitution to find out what's the value of a, b, and c, and d. So I guess the first step we'll do is we let x equals 2. How about we let x equal to 0? If we let x equal to 0, this term, and a term here, and a term there, all of those 3 terms disappeared. Okay, so we should be able to find out what's the value of a. So a is equal to 0, 3 times by 0 plus 2. Now obviously a is just equal to 2, so it's really simple this way. Then we can let x equals to minus 1. If we let x equal to minus 1, all 3 of these 3 terms disappeared. And as you can see, minus 1, if you substitute, they're all equal to 0. So therefore that gives you a minus d is equal to a minus 3 plus 2, and d is equal to 1. Okay, now the next one is a bit tricky. This time, it doesn't matter what number you let x equal to, you're not going to cancel the term that easily now. So we need to probably solve some simultaneous equation after we finish. So we'll start with something that's small and easy. We'll let x equal to 1. So that gives us 8a plus, if we let x equals to 1 here, that becomes 4b plus 2c plus d is equal to 5. Now, since we know what's a and d, so we can substitute this one inside there, and a is equal to 2, d is equal to 1, so that ends up with 4b plus 2c is equal to 5 minus, if we substitute the 2 here, that becomes 16, and minus the last one, which is d, so we need to take away 1 again. Alright, so that should give us 4b plus 2c is equal to minus 12. Alright, we're just going to keep this term here, this equation here. We need to again do another substitution to get to another equation in terms of b and c, so we can solve it simultaneously. And that way we should be able to find out what's b and c. It is pretty annoying. There is no quicker way of solving it unless probably you can use expanding. Well, I guess if you expand all of the left-hand side and try to equating the coefficient, it's also not a good idea of doing that. So I guess maybe that's the only better way of doing it. Alright, so next one is I'm just going to let x equal to 2. Okay, substitute 2 inside. And that will gives me 27a plus 2 plus 1 is 3, and that's 18b plus 6c, and then plus 2d is equal to 8. Alright, so what I did is substitute 2 inside all of those x here, and do all the calculations. You end up with this expression here. Alright, now we're going to do the same thing. We know what a equals to. A is equal to 2, so that's 54. We don't know what's b and c. We know what's d. D is equal to 1, so that becomes 2. So at the end, we end up with 18b plus 6c is equal to minus, I think that's minus 48. Okay, so that becomes my second equation I need. Alright, so to combine these two equations, alright, we should be able to find out what is c and b equals to. Alright, let's just call this equation 1, equation 2. If we times the equation 1 by 3, so I can cancel the c, we end up with 12b plus 6c is minus 36. Alright, and let's just call this equation 3. Now, equation 2 we have is this. Okay, so if we just do 2 minus 3, so we end up with 6b is equal to minus 12, and I'm pretty confident b is minus 2. Alright, so once you have b equal to minus 2, then you can sub b equals to minus 2 into any of the equation 1, 2, or 3 to find out the value of c. Okay, so that becomes minus 8 plus 2c is minus 12, and that gives you minus 4, so c is minus 2 as well. Alright, so after such a long process, we finally got a, b, and c, and d. Let me just write it somewhere here so we are very clear what's a, b, and c. So we know what's a is equal to 2, b is equal to minus 2, c is minus 2, d is 1. Okay, let me just check if that's right. Okay, so that should be right. So now what we need to do is substitute a, b, c, d, all right, into all of this expression here, and we should be able to integrate it that way. All right, so let me just copy this one down so that I don't have to rewrite it again. All right, let's put it here. Okay, so we need to integrate all of those. Now remember, we know what's a, b, c, d. All right, so let's just substitute. That's 2 over x minus 2 over x plus 1 minus 2 over x plus 1 square, and then 1 over x plus 1 to the power of 3 dx. Okay, now we should be able to actually integrate term by term. Shouldn't be that hard anymore now. Okay, so the first one is 2 ln absolute value of x. The second one is just minus 2 ln absolute value of x plus 1. Okay, the next one is a bit tricky. All right, so you need to think about this as a reverse chain rule. So you need to change that one into minus 2 x plus 1 to the power of minus 2, and start using the reverse chain rule to work out the answers there. Okay, so we need to plus 1 for the power, and then we need to find the reciprocal of the power and times to the front, which just gives you a positive 2. So in that case, we'll get positive 2 x plus 1 to the power of 1. And for the last one, same thing applies. We can change the last term into power of minus 3 here. If you think of that term, then we just need to add 1 to the power, find the reciprocal of the power. So we should have like minus 1.5 x plus 1 to the power of minus 2, which obviously you can write in terms of a fraction. So if you're writing this one in terms of a fraction, that's 1 over 2 x plus 1 to the power of 2 plus c. Okay, and that is that's it. So that's the end of the question here. So as you can see, for the key of this question is you need to be able to find a, b, c, d correctly. And then once you find out those a, b, c, d, those constant numbers on the numerator, the rest of the working out should be pretty straightforward. All right, so the final integration is not that hard. Finding a, b, c, d depends on which method you're using. Those takes a while to do it. Yeah, that's all. That's how you do this question here. All right, thanks for watching.